Okay. Is my voice audible now? Can you see me?
Yes, ma'am.
Okay. Second. Is the screen visible?
Yes, ma'am.
Okay.
Yes, ma'am.
See, this is a phone. Okay, I'm holding it. Okay. So only if I position my finger here, only I'll be able to balance. Only then I'll be able to balance this. Or you would have seen the football. Okay. Only if they place their position, the finger at the center, right at the center, or any disc, if you take, only then they will be able to balance it. It will not fall down. So that is nothing but center of gravity. So you will be learning about that also here. And then you had learnt about motion in one dimension, right? In your
Yes, ma'am.
ninth standard.
Yes, yes.
So you had learnt about distance and displacement, right? What is the difference between distance and displacement?
Distance is scalar and
Yes,
displacement is
distance
vector.
is scalar and displacement is vector. Okay, so you're supposed to know the difference between distance, displacement. So here we directly define what is displacement. We don't define the displacement and all here. So we directly write it as displacement. You're supposed to know all those definitions. Okay, and then what about speed and velocity? What is the difference between speed and velocity?
Speed is scalar, velocity is vector.
Yes, speed is scalar. That is nothing but it is related to distance. Okay, distance by time taken is called as speed. Okay, what about displacement? It is nothing but displacement by time. The rate of change of displacement is velocity. Okay,
Velocity.
yes. So here you will be learning. There you learnt about motion in one dimension. Okay, here you will be learning about uniform circular motion. So how if a body rotates, or if a body is moving in a circular path, what happens to that body? So you will be learning about that. You have two types in that, centripetal and centrifugal forces. So you don't have to know. I just told you, that's all. Now we'll be learning about all those things. So the second unit under part A is work, energy, and power. Okay, so what is work? So whenever I do some work, you tell in physics, it is different. Okay, whenever I just take a body and place it on the other side, then work is done. So how is this work measured? Okay, you had learned about gravity, right? Gravitation or a free fall of body.
Yes, ma'am.
Yes,
Okay,
ma'am.
you are supposed to know that also. So those are the basic things which you are supposed to know. So here we will just take those things up and then we'll move on. That's all. A little more is added. That's all. Okay, we connect that with we had learned about gravity there. Okay, we connect that with the work done by the force of gravity here. That's all. So we talk about energy. So what is energy? Energy is the capacity to do work. So units of energy, can anyone tell units of energy?
Joule.
From Joule.
Even Joule.
Yes, you can
Ergs.
measure energy in joule, calories, kilocalories. Okay, so you will be learning about those things and you will be learning about conversions. So from calories to kilocalories, from calories to joules. Okay, and different form of energy. Different forms of energy is nothing but can you guess different forms of energy? This is
Ma'am,
there from,
kinetic potential.
yes, kinetic energy and potential energy. So kinetic energy and potential energy comes under mechanical energy. So you'll be learning about that also. So you will be learning about conversion of kinetic energy, potential energy to kinetic energy. Whenever a body is falling, what will happen to that? So how is your potential energy is getting converted to kinetic energy? And the other forms of energy which you would have learned is about solar energy, wind energy, geothermal energy. That is nothing
Tidal.
but renewable sources of energy. Tidal energy, and then nuclear energy. Yes, you had learned it in ninth, right? So you're supposed to know all those things. You are supposed to just go through it, okay? Before just coming to the class, before attending the class, you're supposed to know all those types, okay? Your solar energy will use what? Sun as a source of energy, okay? This when you would have learned about solar plant and solar cell. right? Yes.
Yes, ma'am.
Yes. Do you know how a dynamo works, how a generator works?
No, ma'am.
Yes. No? Okay. So when I take up this chapter, that was also there in your ninth standard. Okay. Now it's not needed. I will not explain that because it will take a long time to explain all those things. So you will be learning about how those generator works. Okay. So only because of that dynamo or a generator, only then you will be able to convert whatever kind of energy. Suppose I am supposed to convert nuclear energy into electrical energy. So with the help of a generator or a dynamo, I will convert that, or else you will not be able to convert that. So you will be learning about conservation of energy. So applications is nothing but where is it used? Okay, your solar lights. Okay, that is there. Your electricity from wind, your electricity from your hydropower. Okay, so those are the applications. And what about conservation of energy? What do you mean by conservation of energy? You have one sentence itself. What is that? Conservation of energy.
Energy can neither be destroyed nor
Yes.
created, but can only
Yes.
be transferred from one
Yes.
form to another.
Energy can be neither destroyed, can neither be created nor be destroyed. Okay, but it can be transferred from one form to the other form. So you are particularly proving here. That's all. You are deriving that conservation of energy. You're just proving how is that energy conserved. So that is about the second unit, work, energy, and power. Okay. So, and the other third unit which comes under part A is machines. Okay. So you will be learning about some terms related to machines. So what is load and all. So you have some terms related to machine. You will be learning that. See, what is principle of a machine? See, whenever I give some input, so suppose your programs, your computer programs, okay, you just give some input, you just type a program, okay, and then you normally you expect an output, right, from it, right?
Yes,
Yes.
ma'am.
Ah, in the same way, whenever a machine does some work, we normally expect a output. Okay, so there is some principle which is acting on this machine. So how is this machines? How are the machines working? So you will be learning about how machine works and all. So in case, see, to know about the efficiency, what do you mean by efficiency? As a teacher, how efficiently I'm teaching? That is efficiency. Okay, whenever I talk about efficiency of a machine, so I'm giving some input around like 50% of input, so I'm expecting some amount of output from that. So by how much amount of output I get, how efficiently a machine is working, so that is nothing but efficiency of machine. So that you will be learning in this, okay, principle of machine, how a machine works, okay, and what is the efficiency of a machine, okay. And then you will come to levers. So levers are nothing but you would have seen a seesaw, or you would have seen a scissor, how scissor gets cut. I mean, how a scissor can cut a paper, or how a scissor can cut anything. So that is there. So levers and even the opener, bottle opener. Okay, so there are many kinds of levers. You will be learning about types of levers, and you will be seeing how seesaw works, how your scissor works, okay, how your bottle opener works. Okay, there are many things. So, and pulleys and its types. So, pulleys is nothing but you'd have seen a well. Okay, they just take the water, they just tie a rope and rope with a bucket, and then they just take out the water. Have you guys seen it? I don't know. These days it is not used, but in olden days they used to use that. So pulleys is nothing but it is basically to lift the load, heavy load. Pulleys are used to basically lift the heavy load. Okay, so you will be learning different types in it also. So here just one example I told, that is nothing but wells. Okay, there are many things. There are many types of pulleys. Okay, it is used for different pulleys are used for different purposes. So here just one example I gave about wells, that's all. So don't worry, you will be learning it detailedly. Here I'm just telling the gist of it, just to know what you're learning. Okay, so next part is part B. Okay, here you have light. So how can I see objects around me? Anyone?
Ma'am?
Because of
How
the
can I?
light.
Huh? It is because of light. What is happening?
Because they also right?
The light reflects from the surface.
Yes, ma'am.
Yes,
So, like, the
yes,
surface
yes.
you're looking at.
Ma'am, it's cause of irregular
Velocity.
reflection.
Yes, it is. Yes, you're right. Because of irregular reflection, what happens when the sunlight falls on any object? Okay, so that is the incident ray that will get reflected to the observer. Okay, so only then I'll be able to see the things or objects around me. So that is what happening in your that is what is happening in our environment. So only then I am able to see the objects or things around me, whatever tree or whatever, all those things. So, you are supposed to know what is regular reflection and irregular reflection and all. So here we talk about a new concept called as refraction. Okay, this is nothing but suppose I have okay, suppose this is the glass. Okay, this is a mirror or just consider this is a mirror. Okay, or a glass. Okay, this is my incident ray. Okay, and this is my reflected ray. Okay, this incident light and reflected light, and this is normal. Okay, so what happens? So the entire light will not get reflected back. Okay, some part gets transmitted. So some part gets transmitted. What happens? The light ray, when it enters the glass surface, it starts bending. Okay, it is in straight line itself, but there is some deviation. The light ray bends. Okay, so this is called as refraction. This is a new concept, okay, which you will be learning. Don't worry about it. Now you just I just told about this. Okay, don't worry. You will be learning it in detail. Okay, so you had laws of reflection, right? What are those laws of reflection?
Ma'am, the angle of incidence is equal to angle of reflection.
Yes, and the other one
The
is?
incident ray, normal, and reflected ray lie on the same plane.
Yes, 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 correct. So in the same way, you have some laws for refraction also. For refraction phenomenon also, you have laws. In the same way, you have laws for refraction. So you will be learning about all those things here. And then what happens if a light, you will be learning what happens if a light ray travels through the prism. So how is the splitting of lights happening there? So whenever a white light is whenever white light passes through a prism, you could have observed, or I don't know how many of you
I
have
think,
seen
ma'am,
it.
rainbow colors.
Yes, you see rainbow colors. That is nothing but splitting of light. You will understand what is the theory behind it, what is the principle behind it in this chapter. And the next concept is real depth and apparent depth. Okay, so real depth is when I just take sorry, when I just take a bucket of water, okay, and then just put some object, okay, the actual depth is around 10 centimeter, you think, okay, from here, okay. So, but when I see it, okay, it appears that the object is somewhere here, okay. Suppose this is around 8 meters. So 8 centimeters, sorry, 8 centimeter. So actually it is around, the depth of it is around 10 centimeter. But when I look through it, okay, what happens? It seems to be like the object is somewhere here. Okay, so this is called as apparent depth and this is called as real depth. So you will be learning about this also. Okay, so the other thing is consequences. What are the consequences of reflection of light? So you will be learning about that. And the next is total internal reflection. So you would have learned about multiple reflections, right? Yes.
Yes, ma'am.
Okay. So you should know about that to understand this concept, multiple reflection. You should know about, basically, you should know about terms related to reflection and all. So what is incident ray? What is reflected ray? Okay. And angle of incidence, angle of reflection, normal, what is normal, okay, what is point of incidence, okay. So what is point of incidence?
Where the
That's where the
incident
incident ray
strikes the
meets.
mirror.
At the point where the incident ray strikes the surface, that is called as reflecting surface, that is called as point of incidence. So all those are basic things which you are supposed to know, okay. And then we have the next unit is about refraction through a lens, okay. So we had learned about spherical mirrors, right? Mirrors, two kinds of mirrors, concave mirrors and convex mirror. You would have learned about it in your ninth. So spherical mirrors, yes.
Yes, ma'am.
Yes.
Okay. So in that you learned about mirrors. Here you are learning about lenses. Okay. You have two kinds of lenses, that is concave lens and convex lens. Okay. So what do you mean by converging and diverging?
And when light rays meet at a point, it's converging.
Yes, when light rays meet at a point, it is converging. And when light rays move along
Appear
different,
to,
When from a
yes,
yeah,
point they
they
diverge.
move away.
yes, okay. If they meet at a point, it is converging, okay. If they move in different directions, it is called as diverging. So this is your converging and diverging. So you should know about that thing also. So you should know the differences. And then you had learned about the terms related there also. Like you had learned about principal axis. You had learned about center of curvature, radius of curvature, what else? Focal length, focus, right?
Yes, ma'am.
Yes, ma'am.
So you are supposed to know that what is radius of curvature, what is center of curvature, what do you mean by focus, what is focal length, okay? What is principal axis, what is pole, okay? So those things, what is aperture? So those things are important. You have to just go through it, okay? So before getting into this, then you had ray diagrams, right? Over there also you had ray diagrams, like if the object is placed in between focus and radius of curvature, how will the image be formed? Whether the image is real or whether the image is virtual. So what do you mean by real image?
The image is formed by the meeting of the rays
Yes.
and it is formed in front of the mirror.
Yes, it is formed in front of the mirror. What about virtual image?
When the incident rays appear to meet and
It's
they have
from
to be along
behind the
the same.
mirror.
Yes, it appears to be meeting somewhere behind the mirror. The reflected rays appear to meet somewhere behind the mirror. That is called as virtual. The image which is formed in this way, it is called as virtual image. So that is why we call that as virtual. It is actually not meeting. Okay, it is not meeting. Virtual is nothing but it is not in real. Okay, it is not meeting, it is not happening, but still it appears to be meeting somewhere behind the mirror. The reflected rays appear to meet somewhere behind the mirror. So images formed in such a way is called as virtual image. So again, you have ray diagrams here also. So you will have if you will have a particular lens, and then if you just place an object in front of the lens, that is, if you place an object at focus, what will happen to the image? Where will the image be formed? Whether it will be diminished, whether it will be erect, whether it will be magnified. Okay. So whether it is real image or whether it is virtual image, that thing you will be learning here. Again, what about sign conventions? You had sign conventions there also, right? So whatever is there on the left side of your mirror, okay. So this thing was taken to be as negative, right?
Yes,
So
ma'am.
this was taken as positive, and you had learned about sign conventions, right? In your
Yes.
ninth, you had learned about sign
Yes.
conventions. So those things are important. And you had learned about one formula, right? Spherical mirror, for spherical mirror, you had one formula, 1 by f is equals to 1 by u plus 1 by v. Am I right?
Yes, ma'am. Yes, ma'am.
What
Yes.
is that u? U is object distance and v is?
Distance moved.
Image distance.
Yes, you're supposed to know that also. So sign conventions are very important. So only if you understand those concepts like sign conventions, only then you will be able to solve the problem. definitely there is going to be at least one problem from this sign conventions. Definitely you will have one problem from this. So you're supposed to know that. Okay. So that is about refraction through lens. Okay, through a lens. So next is about spectrum. Okay, this is a new kind of thing which is added. You didn't have anything in your ninth, okay, about spectrum and all. So dispersion is nothing but it is about splitting of lights, how a white light gets splitted. Okay, that one, about that you will learn. And electromagnetic spectrum, you would have heard about electromagnetic waves, right? Okay.
Yes, ma'am.
So can electromagnetic waves move in a vacuum, travel in a vacuum?
Yes, ma'am, they can.
Yes, it doesn't need any material medium to travel. Yes, electromagnetic waves. Okay, electromagnetic waves are nothing but basically your visible light, your UV rays, your infrared radiations, your X-rays, your gamma rays. Okay, so here we will be learning about each electromagnetic wave. That is nothing but if I just take infrared radiations, so you will be learning about its wavelength, what is the wavelength of it. You will be learning about the properties of it. You will be learning about the uses of it, like your X-rays and all are used, right, in medical fields. Okay. So you'll be learning about all those things. You will be learning about properties. You'll be learning about applications, where is it used and all. So you'll be learning about each and every electromagnetic wave here. So that is there, that is properties and uses. Then scattering of light, again, when light is passed through a prism, how does it work? What is the principle? What is the theory? Why is it getting splitted into 7 different colors? So you will be learning, basically you will be learning about that in scattering of light. Okay. So next is the part C. In part C you have just one chapter, that is sound. So sound. Now I'm talking. Okay, there are vibrations moving. So how are these vibrations carried? What will carry these vibrations? You are able to hear, right? What is making you to hear the vibrations?
Vibrating particles.
Yeah, the particles in the air vibrate. Okay, as I'm talking, the particle in the air vibrates. Only then you will be able to hear it, right? So a sound always needs what? A material or a particle. There should be a material medium for the sound to travel. So you would have wondered like how your astronauts and all talk in space, even though they don't have, even though there is no matter in space. Okay, it's completely
Don't they
vacuum,
have
right?
radios?
You know what they have? They have a device, okay, that is nothing but microphone, okay, which converts your sound waves into radio waves, okay. So only then radio waves can travel. Radio waves is nothing but electromagnetic waves. So radio waves can travel in vacuum. So that is how they hear the sound. I mean, that is how they communicate to each other, your astronauts and all. So you will be learn. Yes, is it clear?
Yes, ma'am.
Okay. So next is here you will be learning how the sound waves are reflected. So you would have experienced echo. It is echo, right? You would have seen. Have you guys experienced echo? You would have seen it when you
Yes.
go to
Yes,
some
ma'am.
higher altitudes. If you just talk or if you just scream, though you will be able to hear back the sound. So that is because of the reflection. Okay, your sound waves also get reflected. So, and then there is vibrations. Next is about vibrations. So these are this is one of the interesting topic again. So vibrations, you have different types. You have damped vibrations. Okay. So you have forced vibrations. You will get to know like, you know about frequency, amplitude and all, right? So what is frequency? What is amplitude? What is wavelength? Okay. What is frequency?
Ma'am, this is the number of
Vibrations
vibrations
in
in.
1 second.
Yes, ma'am.
Number of vibrations in 1 second. What about amplitude?
It's like the
The
maximum
distance a
displacement.
particle
And
travels
As
from the
the
mean.
maximum distance a particle can travel from its mean position. Yes, yes. So you are supposed to know those things, okay? So how is frequency related to the wavelength? How is velocity of sound related to the frequency and wavelength? You have a formula once more.
Frequency doesn't affect,
Velocity
right?
is equal to frequency into lambda.
Okay,
Yes,
that, okay.
velocity. Yeah, your velocity is equals to f into lambda. You would have learnt about it. Okay. You were talking about velocity of speed doesn't depend on the frequency and wavelength, right? That was about that was in gas.
That's in gas, yes, ma'am.
Yes, in gas. Okay. So it's correct. Yes. Fine. Then you will be learning about those vibrations when you're just learning the sound chapter. You're supposed to know all those things, all those concepts. Okay. So you had another formula V is equals to d by t, distance by time taken. Yes, you had few problems also based on that. Yes.
Yes, ma'am.
Okay, that is also important. You're supposed to know that. So vibrations, then you have resonance. You have a new phenomenon called as resonance. Okay, so I will not explain about it anything over here. So you will learn it. It is a very interesting topic. Okay, concept. Then characteristics of sound is nothing but you will be learning about the loudness. Okay, loudness, pitch. Okay, so loudness, in case of when you take a man, the man's loudness is man is very loud. Okay, whenever a man talks, okay, the sound produced by him is loud when you compare that to women. But the pitch of women is higher than man. So it completely depends on the frequency. Your loudness will depend on amplitude. Your pitch will depend on the frequency. So you're supposed to know what is frequency, what is the amplitude and all. You're supposed to know all those things. Okay. So next is about the sound. It's a very interesting chapter. You will be very keen. It will be very nice to learn all these things. Okay. So that will not be a boring chapter or something like that. So electricity. Next is about electricity and magnetism. You have 3 units here. So current, electricity. Okay. What is current? What is current?
The number of electrons that move per unit time, or the charges that move unit time.
Flow of charges per
Rate of
unit.
flow of charge.
Rate of flow of charges. Okay. So rate of flow of charges per, that is nothing but flow of charges per unit time. What is the unit of charge?
Coulomb.
Coulomb.
Yes, ma'am.
Okay. So what is the unit of current?
Ma'am, ampere.
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 Yes, that
Per
is
second.
nothing but coulomb per second.
Coulomb per second.
Yes. So you'll be learning about that current. Even more, you will have few more things. Okay. Added to it, you will have few more things about current. So and about potential difference also. So you know about potential difference. You had studied about potential difference.
Yes, ma'am.
Yes, ma'am.
Yes. So you will be learning it even more deeply here. Okay. Whatever you had, you are supposed to, those were the basics. Okay. Those were the foundation. Okay. So once you have to go through it. Okay. What about resistance? Do you guys know about resistance?
Yes, ma'am. Ohm's law.
Yes.
Yes. Resistance is nothing but it is just resisting, okay, flow of charges. Okay. Resist is what? I'm not letting it to move. I'm not letting that body to move or something. Okay. That is what resistance means. In case of current, okay, I'm not letting the electrons to move. I'm not letting the flow. I'm not letting the electrons to flow. That is what resistance is. And then you would have learned about Ohm's law also. So you will be learning here that. And electromotive force. So what is electromotive force? Do you guys know?
Ma'am, I don't
No,
think
ma'am.
so.
Ma'am, we
Okay.
haven't learned this.
Okay, so electromotive force is nothing but it sees to that there is continuous flow of charges. Okay, so that is called as electromotive force. Okay, so you don't have to know it now. You will be learning it when you're learning this current electricity unit. So electromotive force is nothing but it sees to that there is flow of charges, continuous flow of charges. Only then your current is produced. If only the electrons are moving continuously, okay, only if it is flowing continuously, only then you're able to, only then you're able to produce the current. So that is nothing but electromotive force. Then you will have resistors again. So you will have different kinds of, you don't have to know what is it, and you will have different combinations of resistors, and then you will have problems related to that also. So it's fine. Okay. Today you have to just know what are we learning. Just don't break your head and all about this. What is this? What is this new word and all? It's fine. Even if you don't know, it's fine. So next is the household circuits. So here it is nothing but the applications. Okay. How does the current work? So how is the circuits in your house? How is the wiring? You would have seen different circuits, right? You would have seen fuse. You would have seen that power supply and all, right? So you will be learning about all those things. You would have seen different kinds of different colors of wires. So why is it green? Why cannot it be yellow? Why is it black? Why cannot it be red? So there are things, okay? So why is it only why is this wire of red color? Why is this wire of black color? Why is this wire of green color? So you have particular meaning to that, okay? So there is something which is indicating the color will indicate something. So we will be learning about that. And the how is power distributed from the how is power distributed to your house? So what are those circuits? How are those circuits? You will be learning about those circuits also. And then here you will also be one thing you will also learn is about how to generate an electricity bill. Okay, you have electricity bill, right? You might get it like every month. So you will know how to calculate those. Okay, what you will know to how to generate the electricity bill here in this chapter. So that is about household circuits. Next is electromagnetism. So you have studied about magnetism there. Okay. Here we are combining both electricity and magnetism together. Okay. Current and magnetism together. That is nothing but electromagnetism. So you will be learning about what is the direction of magnetic field, in which direction the magnetic field is. So you have different types of magnets, that is electromagnet, permanent magnets, and you will be learning about its uses. And you Fleming's rule. Did you have Fleming's rule?
No, ma'am.
No, ma'am.
Okay. So Fleming's rule is nothing but it basically tells you in which direction the current is flowing and in which direction the magnetic field is and all. So you'll be learning about that also in this chapter. So then you will be learning about generators, you will be learning about motors. Okay. It's fine. Okay. All these words are kind of new things. Okay. I know you might not understand it. It's fine. Now, even if I explain, you will not be able to understand. So once we go into that topic, step by step, you will be able to understand all those things. Okay, it's fine. I'm just telling you what all we learn in this. You will be learning about generators. You will be learning about rules. Okay, different rules. There's another rule also which is included here. So there are many experiments. Okay, so you will be learning about all those things in your electromagnetism unit. So you had learned about heat in your class 9 standard, right?
Yes, ma'am.
Yes, yes, ma'am.
Okay,
Yes,
yes.
ma'am.
Heat and temperature. What is the difference between heat and temperature?
Temperature is the degree of hotness or coldness, whereas heat is
Yes,
just
And
energy
heat is a
itself.
form of energy.
yes. See,
Heat is the sum of the total kinetic
yes,
energy of
I
all
wanted that.
particles.
Yes, I wanted that. Okay, what about temperature?
It is the
Temperature.
average of the temperatures of the two bodies placed in contact.
No, 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 no. See, heat I take up. See, heat is nothing but it is the um,
It's the
sum of
difference of heat between two
potential
bodies.
energy and kinetic energy. This is heat. Okay. But when I take up temperature, okay, I am supposed to consider only average kinetic energy. Okay. So this is about temperature. Whenever I talk about temperature, here I'm talking about average kinetic energy. So there are many molecules, right? So each molecule will have its own kinetic energy. So suppose X1 X1 is your kinetic energy of one molecule, and X2 is the kinetic energy of another molecule, X3 is kinetic energy of another molecule. What I do to get average is X1 plus X2 plus X3 divided by 3. So So this will give me the average kinetic energy. So whenever I talk about temperature, I am supposed to talk only about the average kinetic energy. So your potential energy will not be there. So that is the major difference. Okay, is it clear? So you will be learning, I will explain it deeply also. You will be learning it here in calorimetry, heat concept. Okay, so here you will be learning about heat capacity. Uh, that is a new thing for you. So you will be learning about units of, you have learned about units of heat, right?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
calories.
Yes.
1 calorie is about how many joules?
Ma'am, 4.18 joules.
4.18.
4.186 joules. Yes. So you will be learning about few more things here: heat capacity and specific heat capacity. So even if I define it now, you will not be able to understand. So heat capacity is nothing but the amount of heat energy required to raise the temperature by, okay, temperature by 1 degree Celsius. So I will not define it. I will not explain it now. So those are the two things, two new things which you will be learning. Calorimeter is nothing but it is something which measures the heat. So it is nothing but it is measurement of heat is done by with the help of calorimeter. Okay, so it is nothing but a vessel. Okay, it is a vessel. It is made up of a copper. Okay, thin sheet of copper. So this is a device which helps to measure the amount of heat. Okay, you will be learning about its principle. You will have problems on this. Okay, very important. You will have problems on this and this. So these things are, you will learn it. It's very interesting. Okay, so you'll be learning about these. There are problems based on it also. Then what about change of phase? What do you mean by phase? Change of phase? What is phase? We talk about states, right? One state, two. Matter can exist in three different forms. What are those?
Solid, liquid, gas.
Solid, liquid, and
Yes,
gas.
that is what phase is. Okay. Instead of state, I'm using it as a phase. That's all. Okay. Change of phase from solid to liquid. What is it called? Melting.
Yes.
Yes,
So,
ma'am.
so change of phase is nothing but change of a state from one state to another state. So you will be learning about that. So how was heat? How much of amount of heat is required for melting? How much amount of heat is required for the next process for vaporization? So you will be learning about all those things here in calorimetry. So you would have problems on this also. So next, the last unit is about radioactivity. Okay, so here this is another important thing, other important unit and interesting unit. So this comes under nuclear physics. Okay, so here you learn about the atom. What is the structure of atom? So there were several experiments when they came to conclusion that the atom is around something. Atom is looks something like this. Okay, we'll be learning about that. How is the structure of the atom, and how what is present between nucleus? What is present in nucleus? What is present in nucleus? What does it
Protons.
hold?
And protons
From
and
protons and
Protons and
neutrons.
neutrons. Yes, protons and neutrons. What happens if the atom is unstable? So you will be learning about that. If an atom is not stable, okay, what happens if the atom is not stable? So you will be learning about isotopes, isobars, isotones, and all. You know what is isotopes and all?
Yes,
yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, but I've studied about isotopes, isobars, isotones. You're supposed to know that. So, and then you will learn about alpha, beta, gamma radiations. So, all these things are like, why does it happen? Is because if the atom is unstable, only then such kinds of radiations will take place. So, you'll be learning about that. Then you will be learning where is it used, uses of radioactivity. So where are these radiations used? Where are these alpha radiations used? Where are these gamma radiations used? Or where are these beta radiations used? What are the applications of that? So we'll be learning about that. Then you would have studied about nuclear fission and fusion. Have you guys studied?
Ma'am, we haven't studied about it.
Ma'am, we have heard.
Yes, ma'am.
You had nuclear energy, right? So in
Yes.
nuclear energy, so we there it was there was nothing but your nuclear fission and fusion reactions used to give out some amount of energy. So that energy used to get converted to the electrical energy. Basically, that was happening there. So nuclear fusion is nothing but whenever you combine two light nuclei. Fusion is nothing but fusing something. Okay. Whenever I am fusing two nucleus, light nucleus, then it will just give me a heavy nucleus that is called as fusion, and upon that you will have some kind of energy. So there is some energy here. So that is called as fusion. Your fission is just the opposite. Okay, just the opposite. Nucleus will get split into two light nuclei. Okay, two light nuclei. Along with that, neutrons, two or three neutrons are produced. So that is about fission. So don't worry, you will be learning it about it deeply. So that is what your nuclear fission and fusion is. So these are the things which you are going to do in your 10th standard. So the basics, whatever I told, see, basics is nothing but you have to just, I'm not asking you to memorize something or something like that. Just try to understand what is the concept behind it. So you should know what is frequency, you should know what is displacement, you should know what is velocity. We can't be teaching here what is velocity again, right? So I cannot define, I cannot give out the definition of that and then explain what is velocity and all. You're supposed to know that. So only then it will be easier for you to understand the concepts. Okay, you had laws of motion and all there. So you're supposed to know laws of motion. Okay. So you had about heat, you had about temperature, you had about potential energy, you had about kinetic energy. So what is that kinetic energy? What is that potential energy? So and the other thing which you had learned about is in heat chapter is about anomalous expansion of water. Have you guys studied that anomalous expansion of water? It is a very important thing, important concept.
Yes,
Yes,
ma'am.
sir.
Okay. Basically, if I just take any substance, it will expand on heating it. But what happens to water between 0 degrees Celsius to 4 degrees Celsius? Will it expand?
No, ma'am.
No, ma'am, it
It will
contracts.
contract. Okay. So whenever I cool down the other substances, normally whenever I cool down the substance will get contracted, right? Will get contracted. But in case of water, what will happen when it is cooling from 4 degrees Celsius to 0 degrees Celsius?
It'll
It will
expand.
It
It'll
expands when
it
it
will
expand.
cools.
expand. This property of water is called as anomalous expansion of water. So it will expand from 4 degrees Celsius to whenever I cool down the temperature from 4 degrees Celsius to 0 degrees Celsius. That is called as anomalous expansion of water. So that is one of the important things you are supposed to know that. So such things you are supposed to know. Okay, when you before coming to the class. Okay, all those things you're supposed to know all these basic, you should have an idea, all these basic ideas should be there. So only then it will be easier for you to understand the concept. So do you guys have any questions like about the teaching or about anything, or you just want to know anything about me or something?
Okay.
Yes.
Thank you, Anuradha ma'am, for your valuable bridge course.
Yes.
Okay, so what we will do is we will go one by one, and please each one of you tell what you liked or disliked, your feedback basically about this session. Okay, so who wants to start?
Yes,
Look,
Shlok.
Ma'am, I felt that this session it was actually quite interesting because I got to know what was going to be ahead of me and what I'll have to study. And I also found out that you seem to be a very good teacher who has a good understanding, and you genuinely want to help us do better and all of that. Like how you were saying that you're gonna try your best to make sure even the person who didn't like numericals might not find it that bad after you finish teaching them. So I thought it was
Yes.
an enjoyable session and you'll be a good teacher.
Yes, thank you, Shlok.
Ma'am, I had a doubt. So is this only going to be for school level or is it for higher studies too?
uh like For higher studies in the sense?
As in, what do you mean?
Like
The
like
subjects that you're learning,
advanced.
or
No, like my parents basically want me to prepare for IIT JEE and stuff, and they want me to start preparing for that early.
Okay.
yeah, of course, you can do that as well. But if you're going to have group lessons, then it's going to be for school, and that will have to be separate. But we will see how we can do that. But we also have that option.
Cool, that works. Thank you.
Yeah. Any other questions? What did you think about the session, Alina?
It was pretty good and informative. And it'll help me prepare better for 10th grade, and now I know what I need to know this year. So it was
Right.
pretty helpful.
Okay, that's nice. About Madhu?
Others?
Yes, ma'am. So I actually really like this session because like after discussion, I just realized that it's like eighth and ninth concepts, and they've just proved them. Like there are more formulas, and they've proved it's just like
Yes.
advanced level of the eighth and ninth concept we've already done.
Yes.
So it's yeah.
Yes.
Okay. And Manik?
Yes, ma'am, I really enjoyed this session. It summarizes the whole physics part of 10th grade. So, like many chapters are the combination of 8th and ninth concepts. So it basically just helps us to understand the concepts in future.
Yes.
That's good. And Shruti?
Sir, it was very informative. I enjoyed it. But I have a doubt. Like, can you please tell
Yeah,
which
go ahead.
which chapter should we give more emphasis on? Like, should we consider like which one should we give more emphasis for? Like, even for higher grades and even for the boards.
See, you have a particular scheme of marks, okay? So my view is like I don't believe in that you're supposed to give importance to a particular chapter very much and then just leave the other chapter, okay? So you're supposed to concentrate on each unit because you're learning something, right? The concept should be known to you. So just because you need to know, just because you need to get the marks, that kind of education is it's not that good because whenever you go to higher level, you're supposed to know the concepts that is there. Marks you will gain, that is there. Marks on the other side, it is there, but you don't have to specifically give importance to some chapters, but I will be giving you the numericals or the questions, set of questions which you are supposed to give more emphasis on, that is there. But as a teacher, I'm just telling you not to just neglect anything. You just learn everything, okay? Each and every topic is important, okay?
Yes, ma'am. I wasn't going to neglect it or anything.
No,
It's
no,
just
it's
that,
not about.
it's like radioactivity and all is new chapters, right?
Yes,
So
yes.
will that be given like, will there be
No,
more
you will
questions
not
from that?
have difficult questions based on that and all. You will have very no, simple questions. So don't worry about that. For each and every unit, you will have test and you will have set of assignments and all. So you'll be learning about it. Yes, fine.
Okay, thank you, ma'am.
Okay. And Dugali, are you there?
Yeah, it was a very informative session. I got an overview of the syllabus that we'll be covering for 10th. It was very informative and really helped me understand what I'm gonna be preparing for in the next year and what I'm gonna be studying and learning.
Mm-hmm. That's nice. Okay. Do you have any questions?
No.
All right. Okay. So I think that's pretty much it. Ma'am, do you want to add something?
No, so I want you guys to cooperate. I want you guys to respond in the class also. So let your videos be on, okay, during the class. Okay, today it's fine, but in the upcoming classes, I want your videos to be on. And if you have any doubt, just feel free to ask. Let it be anything. Let it be the simplest thing. It's fine. Even if you don't know, it's fine. It's never too late to learn anything. So I can be learning throughout my the entire age, right? So it's fine. Even if you don't know the simpler things, you can just ask. You don't have to be hesitant about it, okay, or feel shy, okay. Don't think what others will think or what the teacher might think and all. It's fine. It's completely fine. Even if you don't know the basic terms, it's fine. You can ask me. I will be there to help you out. So that is the main part of the education, right? So it's fine. You can just you have to just cooperate. That's what I want you guys to be interactive. I want you guys to respond. Okay. So even if you don't understand any concept, okay, you can ask me. You can clear your doubts. Okay. So I will see to that this journey of physics is interesting, and then it should be easier for you guys to learn the physics. So I will make sure that I will try my best to give the best out, and then let us make this journey of our physics interesting. Okay.
Okay, so I think that's pretty much it for today, and let's see tomorrow. Okay, right. Thank you all for
Thank you,
joining.
sir.
Thank you
Thank
all.
you,
Bye,
ma'am.
guys.
Thank you,
Thank
sir.
you,
Thank
ma'am.
you.
Bye.
Thank
Take
you,
care.
ma'am. Bye, ma'am. Have a nice day.
Thank
You
you.
too.